use. Okay. Very good, yes. So Felix is going to present to us cross-linguistic phonotactic constraints in bilingual speech perception.
That's a lot of big words. Well, hello everyone. Pleasure to meet all of you. My name is Felix Huitian. This is the only time I've ever used my mom's last name. So, thank you, Mama, for supporting me. Wish you were here, but you know. All right, let's begin. All right. So, I know it's like 10 in the morning, but I'm gonna tell you guys a bedtime story. So, during infancy, we express ourselves through body language and the occasional yelp. And as we began to age, we learned words and symbols that constituted our native tongue. We familiarized ourselves with our respective grammars, therefore giving birth to the language learning experiences we are so accustomed to. Not only did these languages help us speak, but they also helped us how to think. The way you perceive something in one language might not correlate with the way you perceive something in another language. And today we will use Spanish, English bilinguals to further comprehend this idea. There we go. First, I'm just going to talk about how these two languages work. Spanish does not allow words to begin with S plus consonant structures. In order to address this, a prosthetic E is aggregated at the front of the word. This is why many words such as estudiar and escuela exist in Spanish. Loan words from English that begin with the prohibited sequence are repaired as well. For example, snob to esnob. But it doesn't just stop there. You see, when a monolingual is introduced to an English word such as school, they're more likely to perceive it as school. The repair system of E, S plus consonant is very important in the Spanish language. So let's continue on. So, because this repair system is so strong, it can lead to perceptual illusions. And if one individual learns these two languages, what happens? So we have two languages with very different systems, and we mesh them into one individual. What's going to happen? So, I actually push it a little quickly. My apologies. So according to a study by Palato Oliveira, bilinguals can acquire two distinct language systems. But that doesn't necessarily answer more important questions. Are these two systems able to influence each other? If so, under what conditions? Interestingly enough, Dr. Carlson's previous studies showed that early bilinguals exhibited a reduction in perceptual illusions because of their background English knowledge. Furthermore, the reduction was even greater when bilinguals were English dominant. However, will a reduction appear in late bilinguals that is comparable to early bilinguals? Early bilinguals have a lot of experience in both languages, while late bilinguals learned English at a much later point in life. So, to ask even a more difficult question, if a reduction were to occur, is this interlingual influence malleable? If it is it due to the ambient environment? So let's say you grew up in Granada, Spain. Will learning more Spanish prevent you to be affected by English? Or if you grew up in the US, will English have an effect? And if it's not the environment, is it the immediate language context? And if I switch to Spanish, por un momento, will that have an effect? And now we step into the actual experiment itself. So for my experiment, we focused on two things. So for the first part of the experiment, we created the AX discrimination task, which basically asked participants to compare stimuli, and we look at auditory perception in bilinguals. In the second part of the experiment, we looked at lexical decision, which focuses on the role of phonotactics in lexical processing. And unfortunately, it was only a control experiment, but we gathered a lot of cool data, and I'm very proud of it. Let's begin with the AX discrimination task. In this task, we asked participants to listen to a pair of stimuli and determine if they were the same or not. The stimuli were all pseudo words that began with an A plus S plus consonant structure, or they began with an E plus S and C consonant structure. And the stimuli were either 70 milliseconds long or 14 milliseconds long. The reason why we cut them short is because we tried to see if the Spanish repair system is going to have a role in the way you perceive these vowels. So for the short vowels, they were ambiguous. They were only 14 milliseconds long, and they were not enough to figure out, are they an A, or they're not, are they an E? And we made them, we compared the short vowels to the long vowels. As it turns out, all groups had a hard time distinguishing a long E versus any of the short vowels, as you can see here. The charts up here show that the monolinguals had the toughest time comparing a long E with any of the short vowels, and bilinguals performed a lot better. And another interesting thing is the response times. So the response times, the bilinguals took the longest period of time to distinguish the long E vowel with any of the short vowels. So what did we learn for this experiment? We learned that performances between bilinguals were comparable, so they were about the same, but the time course decision making varied. Bilinguals took a lot longer to respond between the comparisons between the two stimuli, and it turns out that English does have a bit of an effect when you compare the vowels. And unfortunately, when we tried priming them in English, we tried to see if the immediate language constant would have effect when you compare vowels. It didn't. There were no short-term changes, so that answered that question. We weren't able to prime the bilinguals. There was no effect. So now, time for the second experiment. For this experiment, we made participants compare my apologies. I'm thinking faster than I can speak. All right. So for the lexical decision making, instead of making participants compare stimuli based on auditory perception, this time we compared. We asked participants to determine if words were real or not. So this process is a little bit more challenging because we're not making them compare things just based on sound, which is a much lower processing event in the brain. We're asking them to go inside their minds and determine if these words are real or not. So there were three kinds of stimuli. The first kind, the words were unchanged. So we had words that began with E, such as espalda, and we had words that began with any of the other vowels, such as aspecto. And the second set of stimuli, we removed the vowel, and they were espalda or specto. And for the third part, for the third set of stimuli, we just switched the vowels. So espalda to aspaldo, aspecto to especto. So our predictions were that monolinguals would be able to identify the original stimuli fairly quickly. And as we messed around with the rest of the stimuli, it's going to get only harder. So if we remove the E in spalda, they should be fairly quick to identify because of the E repair system. But for the second part, it should be a lot more challenging. And if you modify the initial vowel, we change it to something else, then it's going to get a little trickier. And as it turns out, that's exactly what happened. The original words were identified fairly quickly and correctly. And if the stimuli was originally missing the E, they responded just as quickly and effectively. And if we switched the vowel, well, if they were missing another vowel, then it was a little bit harder. And if we switched the vowel completely, they took the longest amount of time, and they had the most trouble with it. So what did we learn? When it comes to perceptual repair, if the original vowel misses an E, they're going to more likely say it's right, it's a real word. But if it's either missing another vowel or the vowel was switched, they were more likely to deny that that stimuli is a real word. And the next step would be to run this experiment on bilinguals to see if perceptual repair can be effective on this higher level of processing. Well, for this part, I wish to thank everyone for supporting me, being there for me, giving me advice. It's been an incredibly long year and a half, and I still have much to learn, much knowledge to gather. But I really want to thank the PIRE community for giving me this wonderful opportunity to do this research. I want to thank Dr. Krause and Alex McAllister for providing me advice, supporting me, and pushing me to be better. And I want to thank everyone else that's listed on there here, my cohort, my department, and the further members of this project. Thank you.
And there is time for questions.
Yes.
For the results for experiment 1, could you just walk me through them again? I had difficulty following the first time through.
Oh yeah. So
Go
basically for the first part of the experiment, the AX discrimination task. So just a kind of quick overview. So we made participants compare two stimuli, and they were either ASC or ESC pseudo words. So basically we created them this way because we want to see if the repair system imposed by Spanish, so you have to aggregate the E for S as consonant words. We want to see if that would help identify the comparisons. It turns out that when participants were asked to compare a long A versus a short A, they identified them as the same. So when we changed the length of that vowel, it only became harder to identify them as different.
So the perceptual repair.
Yeah. So they made them
problem.
put down false positives.
Okay. Okay. Thank you.
Yeah.
All right. Thank you very much.